Hi guys, welcome to 11.2 on applying transformations to data. When we're talking about doing transformations to data, what we're really talking about is, suppose I apply some sort of a transformation, either I add some number, subtract some number, multiply or divide to the set of data. What happens to our measures of central tendency and our standard deviation and our range? All right? And so the first, right out of the box, we talk a little bit about adding a constant to data values. When a constant is added to every data value in a data set, the following is true. The mean, median, and mode of the new data set can be attained by simply adding the same constant, whatever is being added to each data value, to the mean, median, and mode. All right, so all of our measures of central tendency will essentially be shifted by whatever number we're adding to the set of data. We'll get a look at an example here in just a second. Now the range and the standard deviation are unchanged. Okay, the spread of the data is not any more spread out because we added five to everything or whatever. Okay, and so let's take a look at some midterm scores and let's see what happens to our set of data. All right, in example 1. It says, what happens if we have these scores on a midterm for a chemistry test, 84, 89, and so on and so forth, okay? Every student in the class has also completed a bonus assignment, so the teacher decides to add 5 bonus points to each score. Find the mean, median, and mode, range, and standard deviation of the test scores with and without the bonus points. So let's start with without the bonus points. And let's go ahead and get over to our graphing calculator, and let's enter some of that data. So we go ahead and we type in the data values, and again, it's a heck of a lot easier if we can to see the mode if we sort the data ascending. So we're going to go to sort A, obviously sort ascending, list 1, and let's go ahead and sort that data. So if I go back under my stat menu, you can go under edit and you can see the data values in order. So as I scroll down through the list, it appears that the data value that's the most frequent is 93. All right, so you can see right here, 93 appears twice. So that's going to be our mode. All right, now 93 then is going to go on the third line here. So this is 93, that's our mode. To find mean, median, range, and standard deviation, we're going to go ahead and we're going to calculate some one variable statistics. All right, so let's slide over here and hit our stat menu, and let's calculate one variable statistics on list number 1. All right, so the mean of our set of data, okay, and I have to move my calculator for you guys to be able to see this. The mean of my data, x bar, is given as 90. All right, whoops, there we go. The mean of the data looks like it's going to be 90. Okay, the median we'll get in just a second. We said the mode was 93. What I'm going to skip to right now is the standard deviation. All right, standard deviation is given right here. All right, so that is sigma x, which is 4.79. So we're going to call that 4.8 for the standard deviation. All right, and so now let's scroll down to some of the values down below. And let's take a look at, first of all, the median. Our median is given as 90. And our range is 98 minus 83, which is 15. So if we follow the rule from up above, it tells us that we can simply, to find the new mean, median, mode, the new measures of central tendency, since we're adding 5 points, this becomes 95, this becomes 95, and the new mode becomes 98. Because before, the most frequent number was 93, but when you add 5 to that, it becomes 98. According to the rule also, the standard deviation and the range do not change, and so this should still be 15, and it still should be 4.8. Okay? So we can use the rules if we want to. There's another way that we can use our graphing calculator to get this same piece of data. All right? So if we go back over to our calculator, and I go under Stat, and I go to Edit, I want to go over to list number 2. And up here in list number 2, I want to say, look, list number 2. Well, list number 2, I'd like to look exactly like list number 1, but instead of saying it's list number 1, I want to add 5 points to all the values in list number 1. So once again, let's do that again. All right? So we go up to L2, we go to second, L1, plus 5. So I want list 1 plus 5, and that adds 5 points to all the data values in the first column. As we said before, the mode is 98 now. You can see that 98 is the most frequent occurrence right here. All right? Okay, so let's go ahead and calculate some one variable statistics there. Okay, let's calculate some one variable statistics on that set of data. So we're going to go to Stat, calculate one variable statistics. Now we want to do this on L2. So let's go to L2. And it tells us that our new mean is 95. Our new standard deviation is 4.8. And that's the same as it was before. And that's the same as it was, well, this is the 95 that we said we were going to get, right? And the standard deviation is still 4.8. We said that the mode is 98. It's the most common value. And so now we just have to make sure the median is 95 and the range is still 15. So if I scroll down below, you'll see my new median is 95 and my new range becomes 103 minus 88. That's 15. All right, so there's two ways to approach that problem. You can add 5 to all the data and just go ahead and calculate the mean, median, mode, etc., range and standard deviation. Or we can simply follow the rule that says add 5 to all the central tendencies and keep the range and standard deviation the same. All right, so let's go ahead and take a look back over here. Let's look at what happens if I multiply data values by a constant. If I multiply every single data value by the same constant, everything, mean, median, mode, range, and standard deviation, can be found by multiplying every single measure of central tendency as well as every single of the original statistics by the same constant. So if I multiply everything by 5, I would then multiply range, standard deviation, mean, median, mode, everything by 5. All right? Okay, so the data set lists the winning distances in meters of the women's Olympic javelin throw from 1968 to 2004. Find the mean, median, mode, range, and standard deviation of these distances in meters and in yards. Okay, so the first thing is we have all of this set of data, and so we're going to go ahead and take just a second and type that into our graphing calculator. So I went ahead and typed those data values in for you, and these are the data values that you're looking for. And again, you can pause your video and type yours in as well. What we're going to do then is we want to find our, first of all, our mode. And again, it's hard to find the mode when the data is not in order. So if I go to stat, sort ascending, and we got to tell it we want to sort list number 1. And now if I go back to our stat menu and I edit list number 1, you can see that 20.56 is the most common occurrence. And I can scroll down, guys, but it's 20.56. Okay? All right. Mean, median, range, and standard deviation can be found by our one variable statistics. So stat, calculate one variable statistics on list number 1. And I have my mean is 20.87. I also have my standard deviation is 0.89. All right? Scrolling down below, we find out that our median is 20.8. We'll round that off to 20.8. And my range is 22.41 minus 19.59, and that comes out to 2.82. All right? Now, what I can do then is, because I multiplied every single value in this to change distance in meters to distance in yards, to go from meters to yards, I have to multiply by 1.098 or 1.094. And so to change distance to meters, I multiply by all the data values by 1.094 yards per meter. All right, and so that's going to change all the data values, and I'm not going to go through and actually change the data values, at least not right now. But I know that since I multiplied, every single thing here is going to get multiplied by 1.094. 0.89, and when we multiply all that stuff out, I get 22.83, I get 22.75, I get 22.49, I get 3.09, and finally 0.97. All right? Now, that's one way to do that. The other way we can do it then is to go back to our calculator, go back to stat, and under the edit menu, I want to go up to list number 2 and say, look, to get list number 2, I want to take all the values in list 1, and I want to multiply them by 1.094, because that's the constant we're multiplying everything by. Okay? The data's already in order for us. You can see as I scroll down here, okay, the most common occurrence is 22.493. And as you go back over here, notice that my mode was 22.49. Okay? Let's calculate some one variable statistics. Stat, calculate one variable stats of, whoops, we don't want to do L1. Now we want to do L2 because we want the second list. All right? X bar is 22.83. Notice again, x bar is 22.83. Also notice the standard deviation sigma is given as 0.976, and 0.976, which should probably round to 0.98, but that's okay. All right, let's take a look down below at our values down below. We have to get our median, which is 22.74, and as you notice up here, we had 22.75, so pretty close there. And finally, to find the range, I'm not going to do 24.5 minus 21.4, but you're going to get something in the neighborhood of 3.1, which is pretty close to 3.09. Okay? All right, so that is the set of data. Now, what I want you to do, guys, you're going to do the 2 checkpoint problems. I would strongly encourage you to do the second checkpoint problem first. Do number 2 first, because you already have the data set from example 2 in your calculator. So do number 2 first, then come back to number 1. Pause your video and try those 2, please. All right, so let's go back under stat, and I want to clear out list number 2. List number 2 is no good to me now because that's multiplying the whole set by 1.094. In example 2 now, we want to change this to feet, so we're going to now multiply all those numbers by 3.28. Now, I can multiply all my stuff up above that I had in that chart before for mean, median, mode, range, and standard deviation in that center column. I can multiply every single thing in there by 3.28, but I can also go up here and say, look, I want list number 2 to be list number 1 times 3.28. All right, and there's my new data values. Once again, you can see now that my new mode is going to be the 67.43. All right, and so my mode is 67. We'll call it 44. All right. So my mode is 67.44. And then we're going to have to go to the 1 variable statistics to get the rest. So let's go x bar, standard deviation of x, because I know what order they're going to come in. We can put the range here, and let's put the median here. Okay, and I think that's everything. So let's go ahead and do our 1 variable statistics, stat, calculate 1 variable stats on list number 2. And so list number 2 tells us that my new mean is 68.45. 68.45. My new standard deviation is 2.93. All right, going back over here, let's scroll down below. It tells us that our median is 68.21, 68.2. And my range becomes 73.5 minus 64.2. That comes out to something in the neighborhood of 9.25. All right? Now, if you look at the checkpoint problem up above, basically we're going to subtract an inch from each patient. So you can type in that data, calculate standard deviation, range, mean, median, and mode, and then subtract 1 from each of those values because we're going to lose an inch for each patient. So we're not going to take the time to do that. That concludes lesson 12.2, or I'm sorry, 11.2.